Once again, greetings, amazing students. Welcome to another video from iCampSA. In this video, we're gonna be doing a past paper from 2022, and this is paper 2. The area of focus is trigonometry, and this paper is from Gauteng province. Yeah, it was written in November. Let's get into it. Question 4: if x is equal to 66.4 degrees and y is equal to 114.7 degrees, calculate the following correct to two decimal places. So for 4.1.1 we have what? We have cos x plus y. Cos x plus y. So by looking at the two angles that we have 66 and then we have 114.7. If you add those angles, they are above what? They are above 90 degrees. If they are above 90 degrees, so they most likely they are in which quadrant? They are in quadrant 2. Okay, they could be also be above 180. Let's go ahead. Wanted to say something, but let's go ahead and say cos x is equal cos of 66.4 degrees plus 114.7 degrees. Let's start by adding what is in the bracket first, then I'll say what I wanted to say initially. 114.7 is 181. So this is cos of 181.1 degrees, also above 180. Okay, let's come here quickly, because I want you guys not just to do these things or to trim this thing, but so also internalize what we are doing. These angles, really understand what is going on. So remember the cast method, and those are your quadrants. We have 0 degrees, 90 degrees, 180 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, so and the angle we're dealing with here is 180 degrees. Where is 181 degrees found? It is gonna be found in this quadrant. In quadrant, what is this? Quadrant 3 is gonna be found in quadrant 3, this angle, because it's straighter than 181. Okay, so the terminal arm will be in quadrant 3, and according to trig ratios and according to the cast method that you see here, only 10 is positive or has a positive ratio in quadrant 3. So since here we have cos 181.1 degrees, we expect a negative number because cos is not positive in that quadrant before you even punch in the calculator. Okay, now let's go ahead and punch this in the calculator and see what do we get. 181.1, it gives us a negative 0.99, so it's just a negative 1. It's gonna be, this is equal to negative 1.00. Okay, and that's the answer we get there. That is the answer we get there. So we get a negative answer, which is in confirmation with what we're just doing here, in our understanding of the quadrants and the trig ratios. Okay, so I just wanted to demonstrate that for you guys. Let's go to 4.1.2, 2 sine x. 4.1.2, 2 sine x. 2 sine x. What is x? X is 66.4 degrees. Now sine x is positive in what? Is positive in first and third quadrant. Sorry, in first and second quadrant. And 66 degrees, since it's less than 90 degrees, this is gonna be in first quadrant. So we expect a positive outcome for this one. This is gonna be 2. This is equal to 2 sine, what is x? 66.4 degrees. Then you punch this in your calculator. 2 sine 66.4, we get a positive 1.83 as we expected. Okay, and then next we have cosec x. 4.1.3, cosec x is a reciprocal. We have to change it first. Cosec x is equal to, what is cosec a reciprocal of? Cosec is the reciprocal of sine. So this is equal to 1 over sine x, and then we can substitute the x there. 1 over sine, what is the value of x? Is 66.4 degrees. You punch this in your calculator. What do we get? 1 over 60 sine 66.4. It gives us 1.09. 1.09, and that is the answer. 1.09. That was 4.1.3. okay, hopefully you guys understood and you are still on board. Let's get into 4.2. okay, determine the value of theta correct to one decimal place. Okay, 4.2.1 correct to one decimal place. We have sine theta plus 0.38 is equal to 1. We take that 0.38 to the other side, we'll be left with sine theta is equal to 1 minus 0.38. What is sine theta? Okay, therefore let's isolate theta. Theta is equal to, we take sine to the other side, sine inverse 1 minus 0.38 is what? Is 0.62. Then you punch this in your calculator. Let's see what we get. Sine inverse, we get 38.3 to one decimal place. This is 38.3 degrees, and that is your answer there. That is your answer there. Okay, then let's go to 4.2.2. 4.2.2, we have 2 cot 2 theta is equal to 3. Start by dividing by 2 on both sides. 2 on both sides. Cot 2 theta is equal to 3 over 2. But we can't just transpose cot theta to the other side. Sorry, cot to the other side. We have to change it to tan first. So this is the same as 1 over tan 2 theta is equal to 3 over 2. Let's make tan 2 theta the subject. We're gonna have tan 2 theta is equal to 2 over 3. We take the denominator, we make them the numerators on both sides. That's how we make tan theta the subject. Let's take tan to the other side so that we are left with 2 theta here. So we're gonna have tan inverse of 2 over 3. Okay, calculate that. Tan inverse of 2 over 3 is 33.69. Okay, 2 theta is equal to 33.69. You divide by 2, and then theta therefore is equal to, divide by 2 is equal to 16.8 to one decimal place. Remember, 16.8 degrees here, 16.8 degrees, and there you have it. That is 4.2.2. Let's add a page. Okay, then let's go to do 4.2.3, which is 2 cos 3 theta minus 61.71. okay, that is 4.2.3. we start here in the new page. 4.2.3, we have 2 cos 3 theta minus 60 degrees is equal to 1.71. We start by dividing by 2 on both sides, so that we are left with cos 3 theta minus 60 degrees. And remember, once you see a trig ratio like cos and everything in brackets, you treat it as just one angle. you don't take that 60 degrees now to the other side. Please don't do that. This is just one complete angle. We're gonna deal with it as such until we transpose cos to the other side. Okay, so this is equal to 1.71 over 2. Now we take the cos to the other side, so we're gonna be left with 3 theta minus 60 degrees is equal to cos inverse 1.71 over 2. 1.71 over 2. Okay, and then 3 theta minus 60 degrees. What is the value of that? Cos inverse 1.71 over 2 gives us 31.24. 31.24. Now we take the 60 to the other side. We're gonna be left with 3 theta is equal to 31.24 plus 60 degrees. Then next we divide by 3 on both sides. 3 on both sides to find the value of theta. Therefore theta is equal to 60 divided by 3. Theta is equal to 30.4. 30.4 degrees to 1 decimal place. Okay, and there you have it. That is how we go about solving 2.4.2.3. Okay, that was the last answer in question 4. Let's go to question 5. So question 5. So for question 5.1.1, given that sine theta is equal to 4 over 5 and tan theta is less than 0, determine with the aid of the diagram and without using a calculator tan theta and so forth. Okay, 5.1.1. so 5.1.1, I'll quickly write what we are given. We are given sine theta is equal to 4 over 5. 4 over 5. 4 over 5. Okay, and then that tan theta is less than 0. Tan theta is less than 0, which means tan theta is negative. In other words, since it's less than 0, the ratio of tan theta. Okay, so always when you come across these questions, let's start by finding in which quadrant is our terminal arm gonna be located. In which quadrant is our terminal arm is gonna be located. Okay, so we have the Cartesian plane there. We have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees right there. Okay, and then first thing first, remember our cast method. In first quadrant, all trig ratios are positive. In second quadrant, only the sine trig ratio is positive. In third quadrant, only tan is positive. In fourth quadrant, only the cos is positive. Okay, let's look. What are we given first? We're given that sine theta is equal to 4 over 5. It's a positive. It's positive. So we know that sine theta is positive in first and what is positive in first and second quadrant. And then next we're given that tan theta is less than 0, which is negative. In which quadrant is tan theta is going to be positive? Tan theta is going to be negative. Tan theta is negative in second quadrant and in fourth quadrant, because in second quadrant only sine theta is positive, and in fourth quadrant only cos theta is positive. And where do we have 2 stars? In second quadrant, and that is where our terminal arm is going to be found. That is where our terminal arm is going to be found for tan theta. Okay, and then what are we given? We're given that sine, this is our theta. Sine theta is 4 over 5. That 5 is for the hypotenuse side, and then the 4 is for the opposite side, so the y side. Okay, so we have that. What do we have to do next? We have to calculate the other third side now for the adjacent side, or the value of x, and we do have to use the Pythagoras theorem to do that. So x squared is equal to r squared minus y squared. Okay, so x squared, the adjacent side, what is r squared? It's 5 squared minus y squared, the opposite side is 4 squared. Okay, let me add the page. Okay, 5 squared, we're gonna have x squared. What is 5 squared? Is 25 minus 4 squared is 16, so it's 25 minus 16. We introduce a square root on both sides, a positive and a negative square root. Don't forget that. Therefore, x is gonna be equal to, what is 25 minus 16 is 9. The square root of 9 is what? Is 3. So x is equal to 3, or x is equal to -3. Let's come here. Our arm is where? Our arm is in the second quadrant, and is on the side of the negative x value. So the correct answer here is -3, because x is negative to the left of the y axis, if I may say, so that is the correct answer. X is not equal to 3. Okay, so we now know that x is what? X is -3. What do we have to calculate? Okay, so for 5.1.1 we have here to determine tan theta. So 5.1.1 tan theta is equal to opposite side y over adjacent side, which is x. Therefore, tan theta is going to be, what's the value of y? It's 4 over -3. So we're going to have a -4/3. And that is your final answer for tan theta. Okay, and then next, 5.1.2, we have to determine the value of 2 cos squared theta minus 1. Okay, so this is 5.1.2. 5.1.2, we have to determine 2 cos squared theta plus 1. 2 cos theta squared plus 1. What is cos theta? Cos theta is, what is it? Adjacent over hypotenuse, so it's -3/5. That is cos theta. Therefore, we're going to have what here? We're going to have 2 into -3/5 squared plus 1. Yes, -3/5 squared. Okay, then let's evaluate what is within the bracket. 2 into -3/5 squared, that is gonna be 9/25. 9/25 plus 1. 2 times 9 is 18/25 plus 1. Okay, 18/25 plus 1 is gonna be 25. 18 plus 25. What is 18 plus 25? It's 43/25. That is the final answer, 43/25. Okay, and that is how you go about solving 5.1.2. And then next, 5.2, we are to simplify the following expressions without using a calculator. Cos theta plus sine squared 60 degrees plus √2 multiplied by sec 45 degrees. Okay, so once you are asked not to use a calculator, just know that you have to deal with now special angles. Okay, that is our 5.2. Let me quickly rewrite what we are given there for 5.2. 5.2, we are given cos 0 degrees plus sine squared 60 degrees plus root 2 multiplied by sec 45 degrees, sec 45 degrees. Okay, special angles. Quickest way to make sure you don't mess up, just write your triangles. The first one is for 45 degrees, 45 degrees. We're gonna have 1 and root 2 here. Second one, equilateral triangle, like that one. All angles are equal. Remember, we have 60 degrees here, 60 degrees. We have 30 degrees. These two sides are equal. It's 1 and 1, 2 and 2, and then the third side is root 3. You have to calculate using the Pythagoras theorem. I'm just writing here to remind myself. Okay, so those are the special angles. So first one is cos of 0 degrees. Okay, so this one you have to use the Venn diagram and to understand that, but in right side we don't use Venn diagram, but yes, you can actually what you call this thing, it will need a Venn diagram to show for you what is happening here. Okay, so at cos 0, let's come here. Maybe I will be able to demonstrate for you guys. At cos 0, remember, this is our Cartesian plane or cardinal point. We have 0 degrees, 90 degrees. We have 180 degrees. We have 270 degrees. Okay, and then we have the terminal arm. You remember that arm that rotates, according to theta degrees. That terminal arm is always equal to 2 units. Is always equal to 2 units. Okay, and then as the terminal arm approaches 0, as it approaches 0 degrees, meaning as we make theta smaller and smaller, it also sort of becomes, let's just use r, it becomes what? It becomes equal to x, the adjacent side. If initially, as you see there, the terminal arm was 2, and then while it was still up there, x was what? X was 1. As the terminal arm decreases, look what happens. The value of x, the adjacent side, will now maybe become what? 1.8 or 1.7, up until once the terminal arm is at 0, where theta is at 0 here, where is at 0. And yes, once the terminal arm is at theta, where theta is equal to 0, the terminal arm will be equal to the adjacent side. So the r is equal to x, So we'll have to do, I'll do another lesson for the Venn diagram, but that's the logic here. So for cos 0 degrees, you're gonna have what? Cos, let's say the terminal arm was 2 degrees. So cos 0 degrees, was 2 units. I'm saying r is equal to x at cos 0, so it's gonna have 2 over 2. Therefore cos 0 is always gonna be 1. But you can also use the calculator to double check this cos 0. I was just making this demonstration for you because the statement said you shouldn't use a calculator. You just have to know how to use it. Cos 0 is what? Cos 0 is 1. Now I have to rewrite this thing again so that we know what we are dealing with. Cos 0 degrees plus sine squared 60 degrees plus root 2 sec 45 degrees. This is what we are simplifying without using a calculator. Okay, yeah. don't lose track. Okay, cos 0 degrees is 1. We've already demonstrated that. Plus sine squared 60 degrees. What is sine of 60 degrees? Sine of 60 degrees is what? Opposite over hypotenuse. This is the opposite side. Root 3 over 2. Sine 60 degrees. So we're going to have root 3 over 2 squared. Root 3 over 2 squared plus root 2 sec 45. What is sec? Sec is the reciprocal of what? Of cos. So we're going to have 1 over cos 45 degrees. Cos 45 degrees. So we have 1 plus root 3 squared is going to be 3 over 4 plus root 2 1 over cos 45. What is cos 45? Where is our triangles? Cos 45 is adjacent over hypotenuse, so it's 1 over root 2 multiplied by 1 divided by 1 over root 2, something like that. Close brackets. Okay, this is equal to 1 plus what is 1 plus 3 over 4? We're gonna have the same denominator of 4. 4 plus 3 is 7 plus root 2. 1 over root 2, that will be root 2 again. And then root 2 multiplied by root 2 is gonna be 2. This is equal to 7 over 4 plus root 2 multiplied by root 2 is 2. Okay, we keep the same denominator. We have 4. 7 plus 4 times 2 is 8. Where is 7 plus 8? Is gonna be 15. 15 over 4. Okay, and that is your final answer, simplified without using a calculator, and it was 4 marks. Okay, you don't have to, in your exam, since you'll be working against time, you don't have to draw these triangles, but if they help you memorize, these, if they help you, yes, demonstrate these special angles, you are always welcome to draw them. But if the what you call this thing, the special angles by heart, you don't have to draw these triangles. Okay, let's go to number 5.3. 5.3, let me see if I can. Okay, already added the page. Yeah, let's copy this for 5.3. Come here, you paste, you drop 5.3. Let's go 5.3. Okay, in the diagram below, a person is standing at point A. Person is standing here at point A. Okay, which is 30 meters away from point B. Point A and B are on the same horizontal plane. Okay, the angle of elevation of the first story window at point C from point A is 15 degrees. The angle of elevation of the second story window at point D from point A is 21 degrees. Okay, determine the distance between the two windows. So we have to determine the distance, what distance CD. We have to determine this distance between the two windows CD. Okay, so in order for us to do that, we have to calculate distance CB and distance DB. Okay, we just have to separate these triangles. First one is this one with angle 15 degrees there. We have 30 meters. This is our 5.3. We have 30 meters there. We can calculate side CB, and by using what? Sine trigonometric ratio. So sine of 15 degrees, sorry, we have to use cos. No, not cos tan, because we don't have the hypotenuse side. We were looking for this side and we have this side, so it's opposite over adjacent. So it's gonna be tan of 15 degrees is equal to opposite side CB over adjacent side 30 meters over adjacent side over 30 meters. Okay, therefore CB is equal to 30 tan 15 degrees, 30 tan 15 degrees. Okay, that is CP. And then next we have to calculate DP the same way we calculated CP, but now we're gonna use this bigger angle here because we are looking at the bigger triangle now. We're gonna use the 21 degrees angle. So for DP, the side DP, this is the entire side we are calculating now. For side DP, we're gonna have what? We're gonna have tan 21 degrees is equal to DP over its opposite side over adjacent side over 30 meters. Therefore, DP is equal to 30 tan 21 degrees. But let's come back here. We are looking, what are we asked to calculate? We were asked to determine the distance between the two windows. The distance between the two windows, So we have window C and the window D. This is the distance. What is the distance CD? Distance CD is what? Is DP minus CP. So for distance, that's what we're looking for, DC, or just in simple terms, maybe for you to cope with this, DC plus CP, DC plus CP, this distance here plus this distance is equal to the entire distance, which is DP, is equal to DP. But we are looking for what? For CD or DC. So let's make CD the CD. Let's make CD the, what you call this thing, subject, is equal to DP minus CP. Okay, therefore CD is equal to, what is DP? DP is 30 tan 21 degrees. DP is equal to 30 tan 21 degrees minus, what is CP? CP is 30 tan 15 degrees. 30 tan 15 degrees. Okay, you punch this in your calculator, it should give you distance between these two. So we have tan 30 tan 21 degrees minus 30 tan 15 degrees. And that gives us 3.48. This gives us 3.48 meters. It gives us 3.48 meters. And that is the distance between the two windows. Distance between the two windows. Okay. That is that. Okay. Oh, that was the final question for 5.3. Let's go to question 6. Okay, we are doing some functions here. Okay, so in this one we're interpreting, already been sketched. F at x is equal to a sine theta. We already know now that the sine function is this one, a sine theta, and g at x is equal to g cos x plus 1. It has been shifted 1 unit upwards. 1 unit upwards. So write down the value of a, the coefficient of what? Of sine x, of which is also given by the amplitude, but the amplitude is always positive. So 6.1 a is equal to distance from here to here is what? 1 unit, is equal to 1. And then 6.2, so supposed to write 1 unit. And then determine the range of G. So the graph of G ranges between 2 units and 0. So the range of G, the cosine function y, is the element of from 0 to 2 units. That's the range of G. Determine the amplitude of G from the baseline. How far is the function stretch? Amplitude of G. from the baseline from 1 to 2 is only what, 1 unit. So for 6.3, the amplitude of G, 6.3 amplitude, say amplitude is equal to 1, is equal to 1 unit. Okay, amplitude doesn't have units, so it's equal to 1. For which values of x will f at x be greater or equal to g at x? So we're looking for all those values of x where f at x is above g at x. So let's come here from 0 to 90 degrees. From 0 to 90 degrees, it is g at x that is above f at x, so that doesn't work. But once we get here at 90 degrees, f at x is actually equal to g at x, and it also gets above g at x. Okay, and then up until 80 degrees. Okay, so it's for all the values of x between greater or equal to 90 degrees but less or equal to 180 degrees. That is our 6.4, where x is greater or equal to 90 degrees but less or equal to 180 degrees. Okay, and then for which 6.5, for which values of x is equal of x will g at x minus f at x equal to 2? G at x minus f at x equal to 2. Okay, so we have quite a few values. Let's start from 0. At 0, where x is equal to 0 degrees, we have 2 minus 0 will give us what? Will give us 2. So g at x minus f at x will be equal to 2. So that's the first one. For 6.5, we say where x is equal to 0 degrees. Let's go ahead and look for others. And then here I'm seeing at 270. At 270, g at x is what? G at x is 1, while f at x is negative 1. 1 minus 1 is equal to 2. So where x is equal to 270 degrees. And then as we go ahead, right up until what? 360 and what? 360, where g at x is 2 and f at x is 0. So, and there at 2 and at where x is equal to 360 degrees. So where x is equal to 360 degrees. Those are the values, and it's 3 values of x at 0, 270 and 360, which will give us our 3 marks. And then 6.6, the graph of f is reflected across the x-axis. Write down the equation of the new graph h. So 6.6, when we are reflecting a graph about the x-axis, what do? We introduce a negative sign. So the graph of h at x will be equal to the graph negative the graph of f at x. What is the graph of f at x? Is sine x. Sine x. The graph of f at x is sine x. So therefore h at x is equal to negative sine x. That's the new graph of h at x. Pretty straightforward. Those are your answers there. I hope you guys learned something from today's video. If there's something you don't understand, you can send us a number. Send us a text on WhatsApp. You can leave a comment if this video is posted on YouTube. And you can reach us from this number, which is 0.696704778, and the area code is +2690. I made a mistake. It's +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 +27690 06769. Oh, now obviously I'm forgetting the company's name. What am I doing? Anyway, the lesson has ended, but I will include the number that you can reach us on, guys. Until we meet again, I wish you good luck and good studying. Good luck and good studying. Yes, that is the number. You can text us there.